writing here. See, at t equals to 0th second, means initial condition, velocity at initial is 0. Now, when time is 1 second, that means 9.8 meter per second by 1 second. Means 9.8 by 1. At velocity is this one. So every second, 9.8 is added. See that at 2 second, velocity is 19.6 meter per second. So what is happening here actually? Everything is attracted towards the earth. So if we are in this earth, so everyone is attracted towards the earth. If till its gravitational pull, not apart from that. Where we are getting attracted towards the center of earth. And who is pulling us there? Gravitational force. Who is pulling us there? Gravitational force.
Yeah, it is breaking. Sir is just writing. I guess we are not able to hear him.
Can't hear me?
Sir, for a while we can hear you, sir, but then like it's breaking, sir.
Okay, as I was saying that Earth is what is this who is attracting this? It is due to gravitational force. And
Gravity.
where we are, yes, and where we are getting attracted towards the center of Earth.
Yes, sir, towards the center.
So the acceleration in this condition are in the falling body due to gravitational
is 9.8 meter per second square. Is 9.8 meter per second.
No, it's called acceleration due to gravity. See,
Yeah,
actually,
it's
the 9.8 meter per second.
Sir, I did not understand the above thing, sir.
Slowly, slowly. Slowly, bolo. You are so loud.
No, sir, my mic was pretty close to.
Sir, unable to see. Sir. Sir, I did refresh, but it is not coming to screen.
You just like click the the standard one, right? There will be types of screens, right?
You cannot see my screen. How possible?
So your voice is breaking.
Okay. So what is this? Acceleration in falling body due to gravitational pull, means gravitational force. This acceleration is called acceleration due to gravity.
Sir, I do not understand the above thing.
Which above thing? T equals to 0.
So that t equals to 0, that one thing, yes, sir.
Okay. What it says, at time, when time t equals to 0, initial velocity is 0.
0,
Now-
sir. And then when time is 1 second, it
1 sec-
increases 9.8 meter per second.
1 second.
So every second,
When time equals to 1 second, velocity is 9.8 meter per second. So, and time equals to 2 seconds. So it will become 9.8 plus 9.8, that is 19.6. 19.6. So, as you are saying, correct,
Sir,
every
why did you write
second,
t equals to 15, sir?
Excuse me, sir.
yes,
Sir, Prithvi, unable to see screen share. Did you share, sir?
yeah,
Oh,
He unable to see, na, sir?
everyone is visible, right, for everyone?
Sir, for me it's not, sir.
It's not visible. Refresh your screen.
sir, for me it's
We are
visible,
showing
sir.
only started screen share only showing, sir. It's not coming.
Sir, it's showing for me.
Sir, it is.
sir,
Sir, I can see, sir.
Yes, sir. When we refresh, we are able to see.
Oh, maybe internet issue for Prithvi.
Refresh means where should we do, sir?
If you are attending phone, leave and rejoin. If you are attending in laptop, above you will find option.
He already did, na? Once he left and he joined again.
Try this. Refreshing means like leave that again and join it again.
Yeah, one second.
go to WhatsApp once again.
Yeah. Okay. This is not 15. This is 1 second, and time equals to
Yes, sir, I got confused, sir.
t equals to 2 seconds. So v equals to 19.6. Then so on.
Okay, sir.
Prithvi, now can you see the screen? Prithvi, can you hear me?
Yes, sir.
Can you see with the screen now?
No, sir.
No? Why? Share your screen, show us what's
Restart your
happening.
laptop once.
No, that won't help. Like, show your screen what's happening there.
Sir, if he shares, you can't if you can't share, no, sir.
No. Yeah, that's true. But do one thing. How will you solve it? Can everyone see my screen? Is it visible to everyone?
Yes, sir.
Yes, sir.
Yes, sir, it's visible.
And is there anyone who is not able to see the screen?
I can't see, sir.
Still you can't see between.
So maybe you can once stop presenting and then present back again.
Okay, let's try that.
Yes, sir, it's visible.
Prithvi,
Yes, sir.
is it now?
No, also not, sir.
Not yet.
So maybe he is facing some internet issue.
Yeah.
But because we all are able to see, sir.
Prithvi, you can join through another device.
Okay.
Do one thing. Already left. Okay. So where were we? Yes. This is called gravitational pull. Yes, Prithvi?
I can see, sir.
Very good. Super. So we were doing this one. Okay. So acceleration in falling body due to gravitational pull is called acceleration due to gravity. Now, falling body means freely falling body. How we can say this is called freely falling body? Lalit? How will say
Sir,
that
can
this
you
is
repeat, sir?
yeah. How will say that this is free falling body? How to know that this is free falling body and this is some other thing?
So, like when a body is falling from space and it's just free falling due to gravity.
Not just due to gravity. It is only due to gravity.
Yes, it's only due to gravity, not any
Okay.
external forces.
External
or
force. Very good.
Yes,
So
sir.
free falling we can say when it is falling freely without any external force.
Yes, sir, and per second, like the speed velocity of the object will increase, and so we
Increase.
say it as yes.
As we wrote here, like the values of velocity, it will keep increasing every second.
Yes, sir.
So free falling
That's why it's
body
known as 9 point and like acceleration 9.8 meter per second square.
square. That is 9.8 meter per second square. So what
So
does
every
this
second 9.8
exactly?
uniformly.
So what this
So
meter per
that's why we
second
call this
square?
as uniform motion.
No, accelerated motion. Not uniform motion.
Yes, sir, uniformly accelerated motion.
We can say uniformly accelerated. We cannot say uniform motion, but uniformly accelerated. It is accelerating uniformly.
Every second 9.8 meter.
Yeah,
Yes.
that's we wrote already here, right? Everyone clear with these three things?
Yes, sir.
So every second 9.8 is added for free falling body. And obviously for forced falling body, the force which is applied, that is also creating some extra effort.
Yes, sir, it adds like if you push a ball from like a very tall building and the gravitation and the force which you
Both,
they both add up, sir.
yes, both gives add on to your this velocity. Clear, everyone?
Yes.
Yes, sir.
Free falling, forced falling. It is different. We should understand this. Yes,
So like
Nityashree?
here we're only talking about gravity, that means no external force. But like if you're giving a real life example, then it might be like with force.
Yeah. Okay. Nityashree, yes. Say something.
You are on mute, Nityashree.
Sorry, sir, I raised the hand when you were asking a question to Lalita. That following that question.
You want to answer that. That's what you asked.
Yes, so that time I knew the answer, so I raised my
Okay.
hand.
Fine. Very good. Now something we will write here about G. G is 9.8 meter per second square. It will be plus when it will be plus and when G minus 9.8 meter per second square. Now there are some conditions when we can say that the G is minus and when we can say G will be plus.
So minus is like when it's moving up.
Against.
It's against gravity.
Yes.
Yes, against gravity, then it's minus, and then when it's in
So
favor
when
of
it
Towards Earth.
so this is like going to space or like against gravity,
Example.
going away from Earth. So
ठीक है?
So like when the both the forces are same, like the gravity, when they're balanced, like the force at which you're going up and then the gravity, they both are same. So the object will remain the same, like it won't go up or down.
Yes, it won't go up or down, but which is not possible. You
Yes.
imagine the speed actually. See, 9.8 meter per second square. Just imagine. It's so big value.
Yes, sir.
In 1
Yes,
second,
sir.
right? If you calculate distance and all that, in 1 second, how much speed? It's 9.8 meter per second.
Yes, and then it increases with time.
It's dynamic. It's not fixed here. It's keep increasing.
Yes, sir, it's not fixed and it keeps increasing.
Just take off 10. It's keep increasing, right? 10 seconds, if you think of 10 seconds, it'd be so high value. And that is
Yes,
also
sir.
meter in second, this much meters in second.
Yes, sir, and we'll travel like this much meter per second and then it increases. So after like a minute, it would be so high.
So let's go further. In uniform motion or accelerated motion, let's write uniform acceleration or okay, whatever. Magnitude of acceleration remains
Yes, sir, constant. So it constantly increases.
Which is 9.8. If it is what gravitational acceleration, this if
Yes, so it's like
suppose-
uniform acceleration, equal amounts of velocity.
not all the acceleration. If suppose this acceleration is due to the gravitational acceleration, then only we can say that's right condition.
Yes, sir. Then only if no external forces are acting on it, then we can say that it's uniformly
No,
accelerated.
don't remember that one. See what I'm saying. If acceleration, this acceleration, which we are mentioning right now, it is due to gravity, then 9.8 fixed value. If it is due to some other thing, then it is not that fixed value, it will be some other value.
Yes, so like the velocity will not increase like equal amounts in like equal intervals.
Always. Shall we go further? Any doubt till now? We are going in
No,
the
sir.
we are going in the last part of chapter, that is equation of motion. Is anyone having doubt with
Yes,
this one?
sir. V is equal to U plus AT.
Sir, I have a doubt.
Tell me. Yes, what's the doubt?
Sir, if any object which moves away from the earth will experience some gravitational pull, sir, and other
Yes.
forces?
Yes. Will get same values. See this we wrote here, away from Earth, so G will be minus 9.8.
So it
So
won't be, sir, will it be uniform?
see, it will be also uniform, will decreasing. But so no, not but. So that is the reason if some object has to move out of Earth's gravitation, it requires 11 kilometer per second speed. Actually, it is 11.2. So you understand the meaning of this value, 11 kilometer per second. Can you run this much fast?
Never, sir.
At least not 11, at least 0.5 kilometer per second. Can you run that fast?
Yes.
No, sir.
Can you run?
Sir means not be great.
We can't run
runner,
500.
Sir.
We
Great
can't
runner.
run. Still
Okay,
they
dogs
can't.
can run, no?
No.
No, even they can't. 0.5. Sir, who can run 500 meter per second?
Bullet train speed.
Sir, like Usain Bolt takes like 10 seconds for 100 meter, and how can he travel 500 meter per second?
So which is not possible. Your bullet trains
Yes,
travel
sir.
okay, you just understand speed of sound. What is speed of sound? 340. Let's take 340 meter per.
Yes, sir. Like nobody can travel fast as sound, so like nobody can of course travel like 500 meter per second.
340 meter per second. So this half.
Sir, I mean, like, sir, until now, sir, only like people like there's one world record within 9.8 centimeters they have run 100 meters.
Say again. 9.8
Seconds, sir.
Okay.
Sir, but that was
Seconds,
only
took-
100 meter, right, sir? It can't be 500 meter.
Yes, sir, that's what I'm telling, sir. There's no way like anybody can do it.
Yes, sir. Anybody can do it, sir. Like it will at least take like 1 minute or so.
Whatever it is, so we cannot. It's not possible. This cannot cross speed barrier. This is sound barrier. 340 is a sound barrier.
Yes, sir. No one can like cross the sound barriers, sir.
So which is okay. So the question was asked by this guy. What's his name? Chanakya. Yeah, Prithvi. So we can, yes. There is a gravitational acceleration.
Adu, can I?
What?
No, sir, Nitya sir was on unmute, sir.
So yes, we can, but there will be an acceleration due to gravity. Okay, whenever we are going away or towards whatever it is, there is an acceleration due to gravity. Did you clear it out, Tatvi?
So it will, sir. So like it will be uniform, right? Like when we go away from.
Exactly.
Okay.
Uniformly decreasing here, retardation. Here we can say retardation.
Yes, sir. So like we will gain, sir. Like we will gain speed like 9.8 retardation.
Yes.
Yes, sir.
Okay. Anyone else?
So like sir, in both
Wait,
cases we will
yeah.
gain speed, but in both cases we'll gain speed, but going up the difference is like direction. This is up
Yes,
and down.
direction. It might be this, so it is
Yes,
negative,
sir.
and one is positive.
Yes, sir.
That's all the
Like both
differences.
both the people. Yes.
So is there anyone doubt? Anyone having doubt? Everyone clear? Or shall I call you by name? Zoya?
Yes, sir.
Zoya?
No doubt, sir.
Vishnu? Oh, Vishnu
No,
joined after
no
a long
doubt.
time. Shreya? Okay. Shreya's
Hi,
here.
sir.
Then Vedika?
No doubts.
No doubt.
Manogna?
Sir, I have one doubt.
Yes.
Once, can you like go up, sir? I'll ask. Sir, am I audible?
Oh, you are audible, that's why I'm scrolling up. Yeah, which
No,
one?
sir. Now, if something is falling, sir, 1 second, sir. Sir, can you see my video?
Yeah, you can.
Yes, sir. So if I say the sky, this is the earth, sir. If something is falling from the sky, not here, but if it goes like this and attaches over here, is that possible?
Possible, why not? Satellites are there.
Because sir, like gravity means directly it will pull here. No, sir. If it comes like this and gets attached here, is that like here? Is it
Doesn't it happen? It happens, right? We are all like that only.
We
Our
are,
earth is tilted, first of all.
we are standing there only. We are not inside the earth core.
No, sir. Like I am asking, if something falls, there is like more gravity here. No, sir. But if for everywhere there is gravity, but are there possibilities like it comes like this? It comes like this and comes here, or only here? Not we, sir. Anything falls.
Okay, so let me tell you, it's not necessary that it will be falling with the same speed. It might be more speed, it might be less speed. So suppose when, like, let me give you an example. When we are sending some satellite through a rocket, right? So the residual of those rocket, like if you observe that they are detaching, then remaining portion is going front and remaining portion is coming down to earth. Now, same thing, let's compare with some meteors or asteroids. So when they are falling, when small stone or small dust of space falling on the earth, while falling, it will become high speed because it's already on high speed, and with the earth's gravity, it's falling with double high speed.
Or like it depends, like if external forces are
Wait.
acting like
Wait, Lalit. Let me finish. So when it is falling with that, and it's not free falling, it's forced falling. So due to friction, it will start burning there. Very separate part. So it will be falling down. Now same thing if I compare with the satellite. We are making it fixed on some place. Why satellite is rotating around our Earth? Why it's not falling down? Why it's not going outside? Right? We are making it fixed on one place on an orbit. So there is a reason that depends upon the speed increase or decrease we are there. Depends upon our speed and how airplanes are flying then. Why we are not flying? If we run with that speed, we will fly? No. There are some terms and conditions for airplane to fly. Yeah.
sir, so you like mean if if external forces are acting, then it won't be uniform, right?
Yeah. Correct. So if any external force is acting, it is not uniform.
Yes, so
sir.
like a meteor and all.
Exactly. Yeah. Industry.
Clarified, sir. Thank you, sir.
Okay. Okay. Let's go with the equation of motion. That is first equation motion.
V is equal to U
Yes,
plus
I was
A2.
about to ask. Who knows this first equation of motion?
Sir, I know, sir.
Very good.
So I know.
You know,
V is
very
equal
good.
to U.
I don't know, sir.
No problem.
First equation is v is equal to u plus at. It's like acceleration formula. That's how they derived acceleration.
Exactly.
So like they derive these all equations of motion from the graphs.
Yes. We will do graphical
Using
method also.
yes,
We'll
sir,
do both.
area and all. Yes, sir, area of trapezium and all, and then they derive.
So what is acceleration? Change of velocity. So v minus u by t. So what is v?
Yes, sir. Final velocity. U is initial velocity. A is
minus
acceleration. Initial velocity.
by time. So a equals to v minus u by t. So
Yes, and
at
yes,
equals
so
to
at is equal to v minus
minus
u. U and v is equal to u plus at.
Exactly.
Yes, sir. So like we use this like when the final and the like acceleration is given when they tell to find the initial, or they can like tell like other way around, like find the final velocity and give the both time and
Exactly.
so, and then when they ask distance is the second equation of motion.
Yeah. And we'll derive this one again with the graphical method. Okay, let's do one question with this formula. Let's try this. No, let's first derive equation only. Then we'll do all questions together. We have a lot of questions. Okay, everyone did this one? Should I scroll?
Yes, sir.
So what is the last thing? So v equals to
U plus
AT.
at.
Final equals to initial plus a acceleration into time.
Time. Yes, sir.
You know one thing, if you observe this one, a into t is also a velocity. So we can add those quantity which have same units. Remember one thing, keep in mind. We can add and subtract those quantity which have same unit. But we can multiply and divide any quantity. See here, we are adding this. What is the unit of this velocity u? What is the unit of u?
So initial velocity.
Unit of u will be
So meter per second.
meter per second. Acceleration meter per
Meter per
second.
second square.
meter per second square.
T will be second.
Second.
These are all SI units, sir. And then velocity, final velocity is also meter per second.
A into T, how much? What you will get if I multiply A into T? What
Meter
I
per
get?
second square. Sir,
Meter per second, sir.
sir, meter per second, yes, sir. The S and S will cancel.
So we can add those quantity who have same units.
Yes, sir. And then V should be like positive, like greater than U, or else it will be retardation. A will.
No need for that. No need to remember those things. That we will get when we are having values, we will get negative, we will get positive there itself. In question only it will be mentioned. Not directly, that indirectly it will be mentioned. But you need to remember this. We can add those quantity. No, this one is direct things. But in future also, when we are doing some other things, some other chapter, remember this. We can add those quantity who have same unit. Okay, will you remember everyone?
Yes, sir. Can we play a quiz, sir?
Quiz?
No, sir.
Let's derive the second one, then we can have quiz.
So
Yes,
today we'll
sir.
derive the second one, sir. No quiz.
Yeah, we'll have
Yes,
to derive this one.
Sir, we'll derive it and then play quiz.
Yeah. If we have time, then we'll do it. Okay.
So this is S is equal to UT plus half AT square.
Exactly. So here, average velocity we need to take. So we have here two velocity, it is initial and final. So V plus U by 2. So average means sum of those two by 2 because we have only 2. Initial plus final by 2.
So this is like when the velocity is uniform, we'll find V plus U by T, the mean of the final and initial.
It is derived by which one? Position and time relation.
Yes, sir. This is position and time relations. Sir. So this is like area of like triangle and square. That's why half 80, half because triangle's area is half. That's why it came.
We'll get that also. We'll do with the graph. Graphical representation. Distance equals to this velocity, average velocity to time. Distance here S, V plus U by 2 into time. So V we already got from first equation. Let's name it as number 1. Let's substitute V value. Come on, start doing. Don't wait for me. Substitute V value. Yes, God. Yes, wonderful.
Sir, what you wrote, sir, that up of S.
Distance equals to average velocity into time. Average velocity, this one, same.
Sir, if you do this, you'll get half AT, UT plus half AT square.
Yes, sir.
Plus U into T, sir, by 2. So it will be 2U plus AT, which will be U plus
Sir, I did
U.
not understand it, sir.
What happened? See, this average velocity equals to what? V plus U. Average, how to take average? Sum of those quantities, right? Divide by number. How many number we have? 2. We have 2 velocities here, final and
Yes,
initial.
sir.
Right? Then distance
Yes, sir,
equals
and
to
then 2U plus AT.
distance equals to
S.
speed into time. So your speed is average velocity
Yes, sir.
into time. So
And
V
time
plus
is
U,
time only.
V plus U by 2.
Into T.
So let's substitute V value from equation 1.
Yes,
V,
sir. U plus
U plus
AT.
8. Let's write here from 1. V equals to U
Yes,
plus
sir. Like substituting from 1. So, yes, sir. So then it will be 2U plus AT by 2 into T, and then U plus half AT
2U
square.
plus AT by 2 into T, which
Into
will be
T.
multiply T here
U
inside
plus half AT square.
2T plus 1 by 2
AT square. Yes, sir. And then S. Yes, sir. So this is the second equation.
Yes.
So now quiz.
Did everyone derived by themselves?
Yes, sir.
Yes, sir, I got it, sir.
Super. Manogna? Vedika did okay. Manogna? Sohan? What about you? Zoya?
I got it, yes, sir.
Did this one?
Sir, your voice is breaking.
You did this one? Finished? Both equation?
Yes, sir.
Very good. P? Completed? Jasmita?
Yes, sir, I wrote it.
Yes. Ayush?
Yes, sir, I got.
Done? Okay. Ayesha?
Yes, sir, I got it.
Adya? Adya? Anvisha?
Yes, sir.
Are you with us? No? Shreyashi and Nitya? What about you both?
Yes, sir. Sure, sir.
Sir, once can you explain this last point, sir?
Which one? The last one? Just 2 minutes.
Yes, sir.
Just let me scroll up. Okay. We will substitute this value here from the first. I think that this till here you understood, right?
Yes, sir.
Distance equals to speed into time. So we are substituting value of v from equation number 1. So what is one equation? V equals to u plus 80. Just now we derived in above this equation. So we are substituting here u plus 80 plus u by 2 into t. T is total. So this u plus u will be 2u plus 80 by 2 into t. So let's multiply t inside here and here. It will be 2u t plus 80 squared by 2. So it will be 2ut, sorry, ut plus 80 squared by 2.
Half 80 square. Yes.
Understood.
So that is the half 80 square. Okay, Prithvi, understood?
Yes, sir, understood, sir.
Super. If you didn't understand, then you tell me. I will explain this again.
Understood, sir.
Very good. So join for a quiz. I'll just